In our last video, we learned how to give the equation of a line of best fit by hand, and this is the result that we ended up getting. This is a totally fine way of going about finding a line of best fit, but it is prone to error, and there's not really a lot of consistency there. If you had chosen two different points than I did, you would have probably gotten a slightly different equation than this one right here. And it's kind of tough to say, well, maybe mine was the best one, or yours was the best one. It's hard to say sometimes which is the ideal line of best fits. So in this video, I'm going to show you how you guys can find the line of best fit on your calculators. And in order to do this, I'm going to show you, it works for a TI-83 and TI-84 graphing calculators. Some of you guys may have the TI SmartView program on your computers, which if so, that's great. You can do it on there. If not, either in the classroom or at some points, it's something that you will be expected to do. So it's good to know. If you don't have a calculator in front of you right now when you're watching this, unfortunately just kind of watch and write down the steps, and that way at least you'll have it in your notes when it comes time to do it for real. So first of all, just as kind of a, before I get into, I have all the steps written out already, I want you guys, if you have a calculator with you there, I need you to do something really quick just to change a setting. Go ahead and hit second catalog. Catalog's all the way down here on the 0 key. So if you do that, you're going to be in a big menu that says catalog, and just keep scrolling down until you get to the D's. Under D, there is a choice that says diagnostic on. This is nothing you're going to have to remember how to do yourself, but just that option needs to be on right there to show something like that we're going to need later in the video. So do that. That's like a one-time fix on your calculator. I'll do it for you in class if you forget, but just for your purposes right now, have that done. So I have the steps to this problem written out right here. And it'd probably be a good thing to copy these down so you have them all for yourself. I'm going to talk my way through these steps here, but just so you have it in your notes. It looks like a lot, and it looks like it's going to be awful to do. Honestly, it took me a lot of efforts to write these steps out, think about it, because by now I just know how to do it. And I do it without thinking step 1, 2, 3, 4. So you'll get used to it after seeing it done once or twice. But those are going to be our steps. Now that you guys have your steps written down, I want to show you how this will actually play out on the calculator. So, if you guys have your graphing calculator handy here, I'm going to go ahead and zoom in on my screen right here and talk my way through these different steps. So let's see if I can get zoomed in a bit here. Focus on just my screen, so I'll have to tell you guys for the most part what I'm typing in. Alright. First thing you're going to do is hit the key that says Stats on your calculator. Stats is right next to the left arrow key. It's going to be right there. So I press that button. It's going to take me to a menu that looks like this. I'm going to select Edit, which is my very first choice. So I'm just going to hit Enter on that, and it's going to take me to a menu which may or may not have a bunch of numbers in it already. Like you can see, I already have data typed in my calculator here. The way that you get rid of that data is by hitting the up arrow and selecting the L1 or L2. Make sure it's dark up there like that. I'm going to hit clear. Don't hit delete. Delete wipes out the whole column, which is easily fixed, but it's annoying. Hit clear and then enter. And it just takes out the whole column for me. I'm going to do the same thing. Hit clear and enter and get rid of my L2. Now that I have a completely clear chart right here, I'm going to type my X's in L1 and I'm going to type my Y's in L2. So let's see if I can fit this on my screen here. Kind of odd room there. My X's are going to be, let's see, 0, 10. I'm just typing in the X's for my table. I apologize that I can't actually show them on my screen here. You'll be able to see the Y's in a second. There are my X's. And then I'm going to scroll over right here, and I'm going to type in my Y's. So I have 42, 46, 50, 53, 55, and 57. Notice that my points do line up like they do in the table. 0 has to go with 42, 10 with 46, and so on. That's important. Now you're going to quit out, which means you hit second, and then the button right next to it is quit, to go back to the main screen. Go back into Stat again, and this time we're going to go over to Calc, which is that second choice right there. So we're going to go over to Calc, and the fourth choice down says LinReg. LinReg stands for linear regression. It's just another way of saying a line of best fits. I'm going to hit enter, and hit enter one more time, and my calculator is going to give me some information here, which I'm going to write down on my slide right here, and we'll deal with that in a sec. So I have y equals ax plus b, but then they tell me what a is, and they tell me what b is. So my equation according to my calculator is y equals, when there's a big decimal like that, it's usually 3 spots or so is good. It varies from problem to problem, but that's a pretty good rule of thumb. 0.449x plus, and my b is that number right there. So plus 42.34, 3 if I round. And I'll zoom out a little bit so you can see all that row. And the other thing I'm going to write down, the r squared isn't very, we're not going to deal with that in this class. That doesn't really matter to us. But r does matter. So my r, I'm going to write that down too, is 0.988. So I'm going to zoom back out now, and then I'll talk about what I actually accomplished by doing that. That's basically the process, though. Not as painful as it might initially seem. So this tells us, the calculator just told us, the absolute best line of best fit you can do, the most precise one possible, is right here. 0.449x plus 42.343. So this, put my little head on it, that's from the calculator. So notice our equation is not too bad, actually. It's pretty close. It's not that far off. You can see we did a reasonable job, but apparently this purple one is the best that can be done, according to our calculator here. And I want to close out this video by talking about this r right here. R has a special name called the correlation coefficient. And the correlation coefficient is always going to be a number in between -1 and +1. So I'm going to draw a little number line right here. We got -1 on this end, and we have +1 on this end. So at 0.988, it's between those two numbers. We got 0 right here in the middle. If you get numbers, the correlation coefficient is your calculator's way of saying how strong of a fit it is. Is it a strong correlation or a weak correlation? I would say numbers from about 0.75 to 1 would be considered a strong linear correlation. So strong positive correlation. So that's when it's like a really good fit. And if you remember the scatter plot, I erased it by now, but it was a really close to a line. So that makes sense. We have a r that's really close to 1. That means it does a really good job. Your calculator is saying, yeah, this is really close to a line. If you get numbers from about -0.75 to -1, that would be a strong negative correlation. So if this would have been negative right here, that means it would have been a negative correlation, so my points would have been going down like this in almost a line. I would say anywhere from maybe, and this is there's slight room for discussion here, but I would say probably from -0.5 to 0.75 would be like a weaker correlation. So this would be similar to a weak negative probably. And I'll do the same thing on this side. Some people may argue that 0.4 would be weak, but that's kind of like the in-between right there. Anything in this middle area though, close to 0, means that there's not a strong correlation. So not a good or not a strong correlation. Or in other words, the equation that you get is not that good, and you shouldn't really trust it. So just as a quick thing driving home my point right here, say my points were just all over the place like this. This is my graph. And we do line of best fit on our calculator. We type it in, we do that. Your calculator is going to try to put a line that goes through these points right here, but it can't be done. So your calculator, if you type this in your calculator, it's going to give you an equation. It's going to say, this is my equation. But then what it's going to do, you would probably, if you did this problem, get r equals like maybe 0.08. Super low r in this danger zone right here. Your calculator tried to put a line through it, but that r, your correlation coefficient, is your calculator's way of saying, hey, you shouldn't trust this. I tried my best, but it doesn't fit very well. So pay attention to that number. Close to -1 and +1 is a good sign that this equation is doing what it's supposed to. Bad numbers close to 0 means don't trust this.